You know, you see this shape everywhere. Look at any construction site, a skyscraper going up, a bridge being built. It's there. It is literally the backbone of our world. But have you ever really stopped and wondered about it?
So let's just ask the question, why this eye shape? Is it just kind of convenient, easy to make, or is its specific shape an absolute stroke of genius? Well, the answer is a total masterclass in efficiency.
To really get why the I-beam is so brilliant, we first have to see the invisible forces it's designed to fight every single second of every day. There's a hidden battle going on inside.
Okay, think about it like this. When you put a load on a beam, it bends, right? It kind of makes a smile shape. Well, that smile tells you everything. The material at the very bottom is being stretched apart. That's called tension. And at the very top, it's being squeezed together. That's compression. And these forces, they're strongest right at the outer edges. But here's the crazy part. Right down the dead center of that beam, there's a line of pure calm. It's called the neutral axis. And the material there, it's experiencing almost no stress at all. It's basically just along for the ride. It's lazy material. It adds weight, but it's doing very little to help fight that bending. So the engineering puzzle becomes pretty obvious. How do you get rid of all that lazy, heavy material in the middle and make every single molecule count? Well, the answer, of course, is the I-beam.
And its design is just a perfect division of labor. The wide top and bottom plates, those are called the flanges. They're put way out at the edges, exactly where they can fight those maximum bending forces. And the thin plate in the middle, the web, its job is to handle the internal slicing forces, which we call shear, and those are strongest near the center.
But why? What is it about this shape that makes it so much stiffer? The secret weapon has a name, moment of inertia. And you've actually felt this yourself. Think about bending a ruler when it's lying flat. Pretty easy, right? Now turn it up on its edge and try to bend it. Whoa, way harder. It's the exact same ruler, just arranged differently. That's moment of inertia.
And that is the secret sauce the I-beam is built to exploit. By pushing the most important material, the flanges, as far away from that lazy center line as possible, it gets an exponential boost in stiffness. It's not just a little stronger, it's a lot stronger.
Okay, but how much better are we really talking about here? Talk is cheap, let's prove it. We're going to put an I-beam head-to-head against a solid rectangular beam that is made from the exact same amount of material. And the results, well, they are just staggering. It's not even a fair fight. The solid beam, its stiffness clocks in at about 62.4 units. Okay, not bad. But the I-beam, using the exact same amount of material, hits a whopping 226.
Yup, you heard that right. The I-beam is over 3.5 times stiffer for the exact same weight. That's a 262% jump in performance with zero extra material. I mean, that is just pure, beautiful structural efficiency. And that incredible efficiency is what lets us build the world we see all around us. You want to know how we get skyscrapers that touch the clouds? Bridges that can leap across massive rivers? Or those huge, wide-open warehouses and airports with no columns? You are looking at the reason why.
So the next time you see that simple eye shape silhouetted against the sky on a construction site, you'll know. You're not just looking at a piece of steel. You're looking at one of the most elegant, efficient, and impactful innovations in all of history.